Then, good evening, everybody. This is a little bit of an experiment. I'm trying to go live on two platforms at the same time, and we'll see whether either one of them kicks me off. This is going to be GCSE Science. This is going to be Chemistry Paper 2, AQA, GCSE Chemistry Paper 2. We're going to be looking at a bunch of exam questions. We'll be looking at some 6 markers, some required practicals, any other topics that you particularly want me to go through. I will be trying to keep an eye on the chat, but for the first time, I'm trying to stream stuff via 2 platforms at the same time. So we'll see how long I manage to keep up with that for. So yeah, if you are just joining us, this is going to be GCSE Chemistry, Paper 2. If you haven't already had a good look at your specification, then this is the address you want to have a little look at. So aqa.org.uk/8462. If you would like a copy of the questions that I'm going to be going through, you can go to bit.ly/AQA-Chem2. Okay, so the first questions come through. Do you have an idea of what required practical is most likely to come up? I would say there isn't a way that you can know, right? So there isn't a rule around how frequently things have to be examined. It's not like, oh, this one, it's been the longest since it's come up. So there isn't really, I would say there isn't a lot of point in making predictions. If you are particularly focused on the required practicals this evening, if you head over to YouTube, if you're not there already, and you search for Dr. Bruin's classroom, about 2 months ago, I think, I put up a video that is all of the required practicals in, oh, actually, no, it's longer ago than that. 2 months ago was Chemistry Paper 1. Chemistry Paper 2 I did last year, so it'll be about 12 months ago now. But if you search for the name of my channel and you search for Chemistry Paper 2 required practicals, you will find this whole thing. So we've had a question on TikTok, is this combined science trilogy AQA? Yes, mainly. I have got a few triple bits that we might do towards the end, but I tend to, with the lives, stick to mainly the combined science stuff because obviously that's more relevant to more people. Cool, right, we're going to get going with some of this. So if you do want to follow along with questions, this address here is where you're going to find the ones. I'll do an A-level live once GCSE chemistry is out the way. I'll probably do some over this weekend, but for now I'm focusing on my GCSE folks. So this question is about rates of reaction. Remember, we've got 5 different topics in this exam. Rates of reaction and equilibrium is the first one. So a student investigated the rate of the reaction between a strip of zinc metal, there's our zinc, and 20 centimetres cubed of dilute sulfuric acid with a concentration of 0.5 moles per decimetre cubed. And the equation is this. Which state symbol in the equation for the reaction does not represent one of the 3 states of matter? So we're going to have a little look at our state symbols here. And who can tell me which one of these does not represent a state of matter? Exactly, TR. It's our AQ. So we could say AQ, we could say aqueous, because that is what it stands for. Okay. So the state symbols have already been examined once in paper 1. But just in case you weren't aware, they need to have brackets. Obviously, this question, we're not writing it ourselves. We're just identifying it. But we need to have brackets and we need to be lowercase. So right now, I would say this is common content, foundation and higher tier. This question would be sort of like a grade 4 or 5 question. So it could turn up on either one. Okay, so give 2 observations that the student could make during the reaction. I reckon probably live until about 9. We'll see how we get on. If people are interacting lots and asking lots of questions, we might go a little bit later. Oh, that's really nice. Fleiser U8RC on YouTube. So this is stuff that would be combined, but would also be triple. If you've got triple specific questions, I'm more than happy to answer them. But I'm mainly concentrating on the combined science stuff just because there's more people there. Cool, we'll see you back in a little bit then, Zach. Right, 2 observations that the student could make during the reaction. So observations, I always say to the classes that I teach, it's an observation if my 9-year-old nephew could tell it to me. So things that he will point out, right, great, bubbling, fizzing, effervescence, all of those. So they would be the same marking point. And they are things that he would be able to identify, right? If we're asked for observations, we don't want to be talking about electrons moving and this is reacting with this. Cool. So fizzing, yep, absolutely. And then I think someone did put something else. So effervescence is just the proper chemistry name for bubbling. So that's why I've put them all together, because they are the same marking point. They're just different ways of phrasing it. Okay, so a colour change would be another really good observation, but actually we don't get a colour change for this because sulfuric acid is colourless. Honestly, don't know what paper 2 is going to be like. They are done by different people. Right, the solid disappearing, absolutely. So gas being produced wouldn't get us a mark because you don't see the gas being produced. What you see is the bubbles. Okay, and that's what I mean when I say if it's not something that my nephew could tell me, then it's not an observation. So if I'm going to get my red pen out and say not gas being produced. Okay, because that's a really common answer that people have because like they understand that that's what's happening, but it doesn't count as an observation. All right, student wishes to calculate the rate of production of hydrogen gas. What 2 pieces of measuring apparatus could the student use to determine the rate of production of hydrogen gas? Right, gas syringe is a great shout. So, David, they do tend to give the mark for zinc dissolving, and it makes me really angry every time because it doesn't dissolve. It reacts to make zinc sulfate, and then the zinc sulfate dissolves. But they do tend to accept it. Okay, so we've had someone suggesting a measuring cylinder. We could do that instead. So we could have a measuring cylinder as long as we also had a water trough. Someone suggested a balance. That's not going to help us in this experiment. And trough. Yeah, absolutely. I was about to say Toby, and then I don't know if it actually is Toby. And yes, we're going to need a stopwatch. Okay, so it's really, really important for any practical where you're working out rate. I know that GCSE biology is gone, but it's true for rate of photosynthesis as well. In order for you to work out a rate, you need to have some time. So counting bubbles is not going to help us because this is asking us to calculate a rate. It's not asking us to compare the rates of different reactions. If we were just saying which metal is more reactive, we could do some bubble counting. I'm not sure what you would use the pipette for. So if you're going to use a measuring cylinder, what you do is you take a tank of water, and you take a measuring cylinder and you fill the measuring cylinder with water. And then you have your reaction, say I've got my reaction over here in my test tube, and you'd have a bung, and that bung would have a delivery tube, and the delivery tube goes up into there. So as the gas is produced, this is like all totally full of water. And as the gas gets produced, the bubbles displace the water, so they push the water out of the measuring cylinder, and therefore you can identify how much gas has been produced. So that tends to be what most schools do because gas syringes are expensive and they are fragile. I know this is AQA, but is this similar to IGCSE Edexcel? Honestly, I haven't tutored IGCSE since COVID. And my main memory is that you guys didn't need to know some really easy stuff, but did need to know some really hard stuff. I would say if there's a topic that is relevant to you, then it's going to be the same. So this is rates of reaction right now. Endothermic means that it absorbs energy from the surroundings, which ultimately will cool down those surroundings. Okie doke. Right. Over we go. So we're going to get a little bit mathsy. Exothermic would be the opposite. It gives out energy to the surroundings, heating them up. So a little bit mathsy. We've been given the volume of gas collected in 10 seconds, and that is in centimeters cubed. And we're asked to determine the mean rate in centimeters cubed per second. And we're told not to include any anomalous results. Okay, they quite often put that in. So right now, this would be either tier. This is about grade 4, 5 stuff. This one is probably more grade 5. Yep, I like that definition, Vites. Okay, so they've told us not to include anomalous results. I've got 4 results. Which one of these is anomalous? Which one of these do I not want to include? Absolutely. Yeah, number 4, so 10.3. Even though this is basically just a mean calculation, the removing of the anomaly, that's going to be one of my marks. Okay, so I'm not going to include that one. Then my mean is going to be me adding up this lot. Well, I can do it a couple of ways. Oh no, tell me I didn't forget my calculator. No, okay. So we can do it a couple of ways. We can work out what the mean gas collected was and then go from there, or we could work out the rates and then work out a mean of those. Yeah, you divide by 3 because we're only including 3 pieces of data. So that's going to tell me how much gas was collected in 10 seconds. But they haven't asked me how much gas is collected in 10 seconds. They've asked me to work out a rate. Okay, so concordant is a word that only applies to titration. And since this isn't titration, it's not going to be relevant here. An anomaly is a result that doesn't fit the pattern. Exactly. We're going to divide it by 10. Because that was 10 seconds and I want to know 1 second. Yep, if you're revising for AQA triple, come join the party. Okay, so one thing to flag, just because it's the first time it's come up in particular live, if you're given an answer line, you don't have to write your answer on it. It does help if you've got a bit confused and you've done multiple different things. Yes, this is in the combined science specification, so it is relevant to you. If you've written an answer on the answer line, then the markers have to mark the method that leads to that answer. So if you've written a load of waffle and then the right answer is here, then they will take it. But also it means if you've put something here, even if we've got some good working up here, if it doesn't match this, we can't take it. Okay, so I divided it by 10 because the volume I was given was the volume collected in 10 seconds and the rate is in they're asking me for the rate of reaction. They're not asking me for the volume of gas made in 10 seconds. So to work out rate, you do volume divided by time. Or if it was mass data, then mass divided by time, obviously. I didn't include test 4 because here it says don't include any anomalous results. Yeah, we're going to get to 1.5, fear not. So I got rid of that one because these guys are all pretty close together. And then this is very, very different. Zach, if you're keen on flashcards, then I would head on over to because all my flashcards are saved there. Yes, it's AQA. Yes, it's still relevant for foundation. So whoever said we wouldn't get rid of 14, no, because 14 is not very, very different from these. Yes, we're AQA. Okay, so the student repeats the experiment using 20 centimetre cubed of dilute sulfuric acid with a concentration of 1 mole. Now, I've obviously flipped the page so you can't see anymore. But when we first did this experiment, we had 20 centimetres cubed, so we haven't changed the volume, and we had 0.5 mole per decimetre cubed. Okay, so it's important that we've gone back and seen what we started with. Yeah, so our rate of reaction is going to increase. And it's worth flagging, I have been nice and kind and written describe and explain because I am a good teacher in theory. But very often AQA just write explain. Even though we spend all this time telling kids describe means tell us what means why, very often they just say explain without saying describe. But then one of the marks is for telling you what the rate actually does. Oh, I don't know how to say your name, Atrads. More frequent collisions. That is a beautiful, beautiful answer. So it's really important that you say more frequent collisions or more often. Collisions would be bad grammar, but collisions happening more often or more collisions per second. Just more collisions would be sufficient. Okay, so in this instance, the volume decreasing wouldn't do anything because we're not talking about a gas. So volume's not going to have an impact. So Lily, the point about more successful collisions or more collisions having the activation energy, that's specifically relevant when we start thinking about temperature. If we're just increasing the if we're just increasing the concentration, we're not changing the proportion of those particles that have the activation energy. Okay, right. I reckon I have got some more rates, but shall we do some different topics and kind of keep circling around. So that is more rate stuff. That is more rate stuff. Let's have a little bit of organics. If you're just joining us, folks, we're doing GCSE chemistry, paper 2. If you want to have a little look at the specification because you've forgotten what's in here, this is where we're going to go. So it's not a particular year. You can see all my branding is all over it. It's all stuff that I've written because my kids have used up all the past papers. Okay, guys, I'm gonna rely on you to just start telling people in the chat that we're AQA. We're doing stuff that's about grade 5, so everybody needs to know it because I can't with the constant. Is this combined? Is this higher or foundation? It's too much. Right. Crude oil contains a number of molecules called alkanes. What is an alkane? What do we mean by an alkane? Okay, good ideas there, Toby. Okay, dear Trads, I'm loving the definition. I'm slightly concerned that you said alkene at the start of it. Saturated hydrocarbon, I love. So saturated hydrocarbon would get it the mark. We could also say molecules with the general formula. I don't know why you would say this, but it has been on the mark scheme before. Who's going to tell me what the general formula for an alkane is? Yeah, hydrocarbons with only single bonds would probably just about get it as well. Okay, Ewan, I like the 2N plus 2, but that's not enough on its own. Good job, Adrian. CnH2n plus 2. Nice. So I reckon hydrocarbons with only single covalent bonds would probably just about be enough. People who are asking what saturated means that every atom is making the maximum number of bonds possible, which basically means it's only going to have single bonds. Okie doke. Right. Balancing our equations. So this is cracking. So all we have to remember is that in chemistry, we are never going to make any atoms. We're never going to destroy any atoms. We're going to have the same number of atoms on the left and the right. So over here at the moment, this is very easy because I've only got one reactant. I've got 22 carbon and 46 hydrogen. Now I've got someone trying to give me another product, but that's no good because they haven't asked me to give another product. They've asked me to balance it. Okay. So what I'm going to do is I'm going to subtract this hexane because I can see I've only got one of them. So if I do 22 take 6, that gives me 16. And 46 take 14, that gives me 32. So I know that I'm left with 16 carbons and 32 hydrogens. So I need to think how many of these butenes are going to give me 16 carbons and 32 hydrogens. Exactly, it's going to be 4. So I'm going to put a nice big 4 there. So there are 2 kinds of cracking equation that you might be asked to do. There are ones where you need to add in a product, and there are ones where you need to balance it because they've given you a product. So right now, this is relevant to everyone. This is about grade 5 stuff. It's on triple, it's on combined. Okay, so butene from here is an alkene. Describe the test for alkene. So first up, what actually is our test? I have got a Harbour process question later. Yes, loving it. So bromine water, you might talk about shake it with bromine water or add bromine water, but bromine water is just okay. Cloudy is not going to get it to us. It's going to turn orange to colourless. And it is super, super important that we in colourless, we definitely cannot say anything else. That is the only word that they will accept. There's absolutely no contingency. So yes, this is on the combined science. Electrolysis for AQA was paper 1, so we've already done it. I mean, right now I think we're a lot of year 11s revising for tomorrow's exam. Some schools teach organic in year 10. So you couldn't just say a hydrocarbon for the first one because lots of hydrocarbons that aren't alkanes. And absolutely, to all the people who are saying this is a polymer, yes, it is. The name kind of gives it away, but if I didn't know what the name was, then how would I know that it was a polymer? Right, we've got our repeating unit there, haven't we? We've got the brackets around it, we've got the N. So you don't need to write the definition, but somebody in the chat just asked what a polymer was. So there you go. There is a definition for you. And we know AQA are super picky about this word very. It makes me angry every time. Mr. Dr. De Bruin is literally a polymer chemist. And with all his many degrees in polymer chemistry, he tells me it's absolute rubbish. But we don't care about being right. We care about getting all the marks. I mean, we do care about being right. It makes me angry every time. But there we go. Cool. Right. That was quite a short one, so let's have another organic one. Okay, crude oil contains a number of molecules called alkanes. Tetradecane is an alkane containing 14 carbon atoms. Complete the formula of tetradecane. Some of us are missing 2.1, right? Really important tomorrow, guys, that you are looking down your right-hand margin, looking for everywhere that it says mark, and making sure that you are not missing any silly marks because you skipped a question that you didn't see was there. Okay, so our general formula is CnH2n plus 2, but they're not asking me for the general formula. They're asking me for tetradecane. Excellent. We got a couple of people in there. Thank you, David. Your service is much appreciated. Okay, tetradecane is a fuel. When tetradecane burns in the engines of large vehicles like lorries, carbon particulates may be produced. Which environmental effect does particulates from burning diesel cause? Absolutely, global dimming. So right now we haven't touched any topics that are in triple. We might do some a little bit later, but for now we're just going to keep everyone involved. So global dimming is basically where these particulates, these tiny pieces of carbon or unburned hydrocarbons, go into the atmosphere and they reflect the sun's light. And that means that in areas where there's a lot of carbon particulates in the air, then there's literally less light. So like you can see some really amazing photos from during COVID times when, you know, cars weren't driving around as much. And because of that, quality is much better, and the difference in how it looks inside cities. Okay, to the person who said about, I thought carbon dioxide was produced. Sure, if we've got enough oxygen, then carbon dioxide is produced. That's what we call complete combustion. But when we have incomplete combustion, that produces carbon monoxide and also carbon particulates. Right, lots of people moving on to our next one. So yes, we can have respiratory issues. Sorry, that was harder to say than I thought. Respiratory issues. And we can also have acid rain. So I've got some people mentioning effects of acid rain. So things like breaking down limestone, things like killing plants, but they would all come under acid rain. So the person asking for an equation, there isn't a standard equation for incomplete combustion because you don't know what proportion of carbon particulates and carbon monoxide you're going to be given. So the exam board could choose to give you a partial equation to balance. So for instance, they could tell you that it's just completely carbon monoxide and get you to balance that, but they couldn't just be like, oh, tetradecane combusts incompletely. Can you give me an equation for that? Because there's no way that you would be able to know. No, health issues or breathing issues wouldn't be sufficient. No, this is not a predicted paper. It's just a bunch of questions that I've written that are for the AQA chemistry topic because my kids have run out of papers, and I thought it might be useful to go through some because I find that revising with exam questions tends to be more useful than just reteaching. Okay, so tetradecane is separated from crude oil by fractional distillation. Describe the process of fractional distillation. So first up, we want to mention that we're going to heat the crude oil until most hydrocarbons evaporate. It's going to be a struggle to fit this into 6 lines, but I'm going to do my best. You don't usually need a temperature, but we'll say 350 degrees C because, you know, it's good to be precise if we can. Then we're going to pump it into a fractionating column. And then in that fractionating column, there is a temperature gradient. So right, this has come up before as a common content 6 marker, so grade 4 to 5. It's been a little while since it's come up as a 6 marker, but it's definitely come up at least twice. So there's temperature gradient. If you wanted to just say exactly, someone's just beaten me to it, and I can't read their username because it's all in fancy writing. It might say blessing. So if you just said it's hot at the bottom and cool at the top, that is explaining what it is. Yes, if you go to bit.ly/AQAchem2, all lowercase, I've uploaded all of these. So no, I said you don't need to know the temperatures, but just it's worth a bit of extra detail. Definitely not going to be a concentration gradient. It's not a concentration gradient, it's a temperature gradient. So we've got our temperature gradient. Different fractions have different boiling points. And then we're going to have the vapors rise, cool, and condense when they reach the height that corresponds to their boiling point. No, this is not triple. This is combined science. This is a really common 6 marker for combined science for organic chemistry. So definitely one that we all need to know. And then it's always worth putting in something about very large hydrocarbons don't evaporate. Or you could talk about the very, very small ones that don't ever condense. And are collected as residue, or you might have called it bitumen. Either name will do. So yes, absolutely. If you're doing triple, you need to know every single thing that the combined scientists know. So it's definitely worth revising those things. So the temperature is going to vary based on the exact fractionating column. So usually anything between 350 and 450 would be fine. We definitely want to make sure that we have our state changes named in there. It's really common that people talk about heating and cooling, but they don't say heat until it evaporates, cool until it condenses. I'm just kind of highlighting the things that we absolutely need in there to get our marks. Which part of the column would you go if you had high boiling point? So if it's got a high boiling point, it will be collected near the bottom, because if you imagine, I'm going to shove this over. Let's say it's 350 here, 300 here, 250 here. You know, you get the idea. It's getting cooler as it goes up. And so as each molecule reaches the height of its boiling point, it turns back into a liquid. Yeah, so our bitumen would, or our residue would come out here because it just wouldn't even evaporate. And then as we go up, things get lower and lower and lower. So the last point is very often in there as like the final marking point. So when you do an extended response question, like a 6-mark question, there are certain things you have to do to get into level 1, level 2, level 3. So that's 1 to 2 marks, 3 to 4 marks, 5 to 6 marks. And then usually your 6th mark is just for added detail. Haven't done any equilibrium yet, hopefully going to do some. And that added detail could be lots of different things. So it could be, when you talk about the boiling points, talking about why they have different boiling points, and talking about the fact that different longer hydrocarbons have stronger weak intermolecular forces, and so that leads them to have a higher boiling point. Or it could be about adding in some detail about the things that don't evaporate. Okay, has everyone who wants to get a screenshot got a screenshot? So that's a 6-mark answer. Cool. Right. Somebody just mentioned some equilibrium. So let's do a little bit of equilibrium. Now, annoyingly, I tried to print some stuff and it all went a bit wrong. So I've got some really straightforward. Yeah, in fact, I think I've only got one equilibrium. I've got quite an easy equilibrium, which is not saying it's an easy question because equilibrium is never easy. But we might need to write some more stuff. Anyway, yes, I will do some A-level chemistry probably over the weekend, if not on Monday. Right now, I'm just focusing on these guys. Cool. Sulfur trioxide can be made from sulfur dioxide. Remember, if they're telling you about a chemical that you haven't met before, they are going to give you the symbols so that you don't need to freak out about it. The equation for the reaction is this. The temperature and pressure of the reaction can be changed to increase the yield of sulfur trioxide at equilibrium. So yield means how much is made. Okay. How does the equation show that the reaction is reversible? Yeah, absolutely. The symbol, the arrow in the middle. So you could say something like that. So you are supposed to recognize that arrow. You're also supposed to be able to draw that arrow. So I would say, if you're not already used to it, do a little practice, because sometimes we get people sort of doing like something like that where they're like, oh, I remember it said like a double-headed arrow, whatever. But I don't know. So none of that. Like, obviously this time they've given it to you, you can just copy it. But for the future, so equilibrium does come up in foundation as well. Not this bit is not in foundation, but these are. Okay, so what do we mean by equilibrium? Oh, thanks, Lizzie. Right, I'm loving it. So we've got forward reaction and backward reaction both taking place. And they're taking place at equal rates. And it's got to be what do we need as well as a reversible reaction and both of those happening, what do we need? Because this reaction is not always going to be at equilibrium. Absolutely closed system. I've also realised we've been online for half an hour and I've not yet said, if you've got friends who are revising, drop them a little invite, share the live. Let's see if we can get a few more people on here. So a closed system. Exactly. I knew someone was going to ask what it is. Closed system means basically we've got a box and nothing can get in or out, but we're not allowed to just say nothing. So we're going to say no matter and no energy. Omar has arrived. Can get in or out. So I'm on 1.2 of equilibrium, but I've been sort of going back and forwards about different topics. Sorry, I know lots of wonderful people have arrived. It's just that I think Omar has been in literally every live I've done this year, including all the GCSE and A-level ones. So it kind of makes me a little happy. Okay, so here I'm not saying that you need to include this. I'm just saying, people saying what is a closed system, and you could get a question that asks you what is a closed system. Don't need to include for this cue. There is not a mark scheme at the link because I wrote most of these this afternoon, so I haven't got around to producing mark schemes yet. Yeah, so Kathy, I would definitely say that is a good thing to have up your sleeve. I tend to kind of overwrite for these questions and put too much in. For year 12, when we ask the same question, you absolutely do have to include that. So this particular one, I think I ripped out of a past paper, and this was the mark scheme for it. But there is definitely nothing wrong with saying concentrations of reactants and products are unchanging. Please don't write R's and P's in your exam. I just don't have enough room. Yeah, I seem to. I mean, I'm not making any promises about physics because this is taking up a lot of time. But I do seem to have done every paper so far. So yeah, I expect that physics will happen. Okay, so describe and explain what will happen to the yield of sulfur trioxide if the pressure is increased. When we have a question about pressure, it has to involve gases, right? So this one, it is relevant, but if we were doing, I don't know, my brain has just totally forgotten every reversible reaction that doesn't involve gases. But if it didn't involve gases, then we couldn't talk about pressure. But we can. So what we're going to do is we're going to look at our symbol equation and we're going to count up how many molecules of gas we have on the left and how many molecules of gas we have on the right. So here we've got 1, 2, 3, and here we've got, oh, here we should have 2, but I forgot to balance it. My bad. Sorry, everybody. So they definitely don't. That's such a good point, Francesca. I'm really glad you brought it up. They don't have the same concentration. Let me grab my pad. So if you imagine you're doing a chemical reaction, all right, so this is time and this is concentration. And we're going to have a reaction where A and B turn into C and D. Then we start off with loads of A until it reaches equilibrium. And we get some of C and D. Okay. And you can see that those are not the same as each other. Okay. So the entire, there's a huge chemical industry based around trying to make there be as much C and D as possible and as little A and B as possible, because you don't want leftover reactants. Okay. So they are not going to be the same as each other. It's a real problem that because most people learn about equilibrium in the context of diffusion in biology first, that is a blindingly rare example where everything does balance equally. And so it kind of confuses a little bit. Okay, so to the people who are asking, how do we count the gases? Let's just have a couple of other examples quickly so you can see what we mean. So we're literally looking at the coefficients and remembering, of course, that chemists are lazy and we don't write the number 1, but really there is a number 1 there and there is a number 1 there and there is a number 1 there. And we're literally looking at these coefficients, how many molecules do we have on this side? So on this side, we have 4 moles and 2. And here we have 4 moles and 3. So this is kind of linked to the Haber process. This one that I've put here actually is the Haber process, just because it was an equation that I had in my head. For the purposes of chemistry, absolutely nothing. Whenever we talk about equilibrium, we are talking about dynamic equilibrium and we just don't give it its full name. The reason it's called dynamic is that it hasn't actually stopped. The forward process is still carrying on and the reverse process is still carrying on. It's just that because they're happening at the same rate, you can't see what's going on. Anyway, back to our actual question. So we've got 3 moles here, 2 moles here. So first thing we're going to do, whenever they talk about anything changing, we're going to say equilibrium will shift to, and then you're basically going to undo whatever they've said. So here they've said pressure is increased. So we're going to say to decrease pressure. Okay. And you can always do that, even if you have no idea what's going on with equilibrium. Le Chatelier's principle tells us the position of equilibrium will shift to counteract the changing conditions. Right, that's what it says. So whatever they have said, then we want that line in there. So now we're going to get to the direction and to the which reaction is being favoured. So yes, this comes up on combined. This particular one would only be combined higher. Okay, if you're doing foundation, you don't need to be able to explain what moves on. No, in a closed system, energy can't get in or out. Otherwise, it wouldn't be closed. Okay, so equilibrium is going to shift to decrease pressure. The way we decrease pressure is by moving to this side, which has fewer moles. So we can say it shifts right. The forward reaction is favoured. Very often, those two are included as the same marking point. I tend to just write one. I just tend to write both. So left is the one that makes an L. It shifts to the right because the right-hand side has fewer molecules. Yes. So if we decreased pressure, then the reverse would happen. So if there's a change in concentration, then we need to basically, if this was aqueous and we were suddenly increasing the concentration of one of these, then it would push it this way. Fewer molecules of gas. I've got a question on YouTube about the temperature. So, yes, the person who's answered you is absolutely right. So, if we had a question that we said temperature was increased, this particular question, we wouldn't be able to answer that right now because I haven't given you enough information. But if temperature increases, we'd start off equilibrium shifts to decrease temperature. And then the way that we would decrease the temperature is by favouring the endothermic reaction. But here I haven't told you what's exothermic and what's endothermic, so you can't answer it. I know that SO2 is 2 moles because I screwed up. Just when I wrote this out, I just didn't balance it properly. But it would have to be 2 because if you've got 2 sulfur dioxides, you've got 2 sulfurs. So therefore, you're going to need 2 of these. Caleb, a dibromoalkane is an alkane that has 2 bromine atoms in it, and I'm not sure why you're asking me. Oh, put it on one of the flashcards. No, I think I had some dichloroalkanes on the flashcards, but I don't think I had any dibromoalkanes. Yes, absolutely. So if they were going to ask you about temperature, then they would tell you one of the, like they would say, oh, the forward reaction here is exothermic. Go forth and answer. So what I'm saying is here, we wouldn't be able to answer that question. Oh, Yusuf is really keen. All right, calm down. So equilibrium's going to shifts right because there are a fewer molecules of gas. Therefore, the yield increases. Sorry, guys, I'm not allowed to talk to people in the chat because people get angry if I don't finish the question fast enough. So yield means how much is made. So with most questions, I would describe first and explain later. But with equilibrium, I tend to find that I need to kind of think through the process to get that. We probably will get to some practicals, but at the moment we're kind of going through these. If you are in need of practicals, then if you go to YouTube and you search for Dr. De Bruin's classroom, then look for the 6-mark challenge, and I've gone through model answers for every single practical. Okay, right. A catalyst is added to increase the rate of reaction. So that's annoying because we're thinking, oh, it would be nice to get a mark because we could say it increases the rate of reaction. But they want to know how. So we're going to say a catalyst provides an alternative pathway with a lower activation energy. And if we were feeling really smug, we might want to say, so a higher proportion of collisions are successful. Although, to be honest, I wouldn't be expecting them to want you to say that unless it was a question right at the end of the paper. Yes, that's right, Jasmine. So the catalyst will speed up the forward reaction, but it will also speed up the reverse reaction. And so therefore the position of equilibrium isn't going to change. Not going to go through any OCR questions because I don't teach OCR. So we had this picture of our equilibrium up here. If I was going to add a catalyst, then I would get something like this. So we've got the same position. So we're making, like, my pink line is at the same height and my blue line is at the same height, but it gets there faster. So catalysts is foundation. The position of equilibrium is not. Yeah, we have got a tangent question in here somewhere. Oh, is it the one that didn't print? No, it's not the one that didn't print. Hold on. So we went over the rest of this. Guys, do you think I need to block Yusuf? Yes, this is AQA. It's getting a bit tiresome, Yusuf. Okay, so we went through the rest of this question earlier, but I forgot that there was an extra page. Yeah, I think we might need to. Okay, so I can't block him until he comes up again. Let's try. Oh, sorry, YouTube. We're just going to move you out of the way because right now you're blocking TikTok and I can't block people. Zoop, zoop. So peat bogs could come up as like a single 1 mark in the atmosphere topic. There we go. Right, so someone asked about tangents. So another student completes the same reaction. This is going way back to the very first question that we did. It was, I think it was zinc and sulfuric acid, but not hugely relevant which reaction it is. Determine the rate of reaction at 150 seconds. Now, the big mistake that people are going to make with this is that they try to work out the mean rate of reaction. So I'm going to do a little thing over here because you could be asked about mean. If I was asked about the mean rate for the whole thing, then I would be going, okay, in the whole thing, it takes 250 centimeters cubed out of 350 seconds. So what is that going to be? So that would be 0.71 centimeters cubed per second. But that's not what they're asking. They're asking me to do it at a specific point, which is 150, right? So I'm going to need to draw a tangent. And as long-term followers will know, every day this week I've forgotten to bring my ruler home from school. So we're going to use this very nice coaster instead. I've upgraded from my my highlighter box. And the thing about a tangent, oh, that's the dodgy tangent, is that you want it to be as long as possible, right? Because the longer your tangent is, the more accurate an answer you're going to get. So the idea of a tangent is that it is a long straight line that is touching the curve in just one place. Maybe I am your chemistry teacher, although you would probably know that given that Dr. De Bruin really is my real name. It's not just like a stage name. Not triple. Yeah, I mean, I would always extend it the whole way. Yeah, to be fair, this is worth more than 2 marks. I think that's me having not changed stuff. So what you would usually get is you would usually get a mark for drawing your tangent. Then you would get a mark for correctly reading your numbers off your graph, which I've made very challenging because I've just drawn it really badly with the coaster. So my change in Y here is 200 centimeters cubed. And my change in X here is 300 seconds. So that would be worth a second mark. Would you join the ends to the lining of the graph? As in, would I join that up? No. Max, are you making fun of my tangent because I drew it with a coaster? Or are you asking? I can't tell if you're being like, Miss, why have you drawn a tangent? Or if you're being like, what is that tangent, Miss? That's so dodgy. Yeah, bigger the more accurate. So 1 mark for drawing the tangent. 1 mark for correctly reading off my volume and my time. 1 mark for knowing to divide the volume by the time. And 1 mark for my answer. So yeah, that should definitely be a 4 mark question. So I mean, you can make make a triangle just to kind of make it really, really obvious what you're doing. And to be honest, that's probably a good idea because it means that if you've picked some really weird numbers, then your examiner can kind of get a better idea of what you were aiming for. But if you're good at reading the graph, then you shouldn't need to. We could probably do a bit of bioleaching and phytomining. No, like how you joined Hold on. No, like how you joined, now the tangents ends to the lining on the top all the way across the graph. As in going up to there? Yeah, so I would do my tangent until, certainly do it until you hit a major grid line, because that's going to make it easier to read, right? You're far less likely to make a mistake if you're reading it from 300 than if you're reading it from like 280 or something and you get the scale wrong. Organic chemistry is not triple. Would we be allowed a range? Yeah, so for tangent questions, they always give a range in the mark scheme, because there's going to be a little bit of wiggle room of like what an acceptable tangent is. Okay, right. We will do some atmosphere stuff because someone did ask about atmosphere ages ago and I forgot. And then we can have a little look at some bioleaching and phytomining. So originally I said I'd be live until 9. This is going quite well. This is going better than the other ones did. I feel like I should do one of those things where it's like, oh, if we get 300 people watching or something, I'll go past 9. I don't know. How do you know where to draw the line in a tangent? Because in the question, it said at 150 seconds. So I looked at 150 seconds. I went, there's 150 seconds. And then I put my ruler, or rather my coaster, in such a way that the flat line was lining up with the curve there. So drawing tangents is not foundation. Drawing tangents is going to be just for your higher tiers. Right. This, however, is going to be foundation. I'm really sorry, Martha, but I've never taught the Edexcel GCSE. I've only taught Edexcel IGCSE, and that was 6 years ago. Right, excellent. So someone on YouTube has said Venus. No, it's not triple. That was rates of reaction. If we're not dividing the change in y over change in x. Yes, I did divide the change in y over change in x. Right. Okay, so someone on YouTube has said Venus. People on TikTok have said Mars. You are both right. Obviously, where they say to you name one planet, and the AQA are nice, they always put it in bold, we would only name one, but I'm naming both because they're both right. People on YouTube are like, what's going on? I'm just showing because people on TikTok are asking things. Okay, so Venus or Mars would be fine, but we're only going to write down one answer. 2.7 billion years ago, the proportion of oxygen in the Earth's atmosphere began to rise. Why did this occur? I don't know why you would think the gradient would be negative. It was going up. Right, I'm liking this. So we've got photosynthesis. I'm not sure what you mean by why is it Mars or Venus, because that is the answer, because that is a fact that is listed in your specification. And now I've written a silly thing because I'm trying to talk at the same time as write. Yeah, like it's a fact. Okay, in fact, I'm going to change this to be photosynthesis by algae because no one is using photosynthetic as an adjective. So they've said 2.7 billion years ago, which means it's going to be algae. Yeah, I absolutely could write photosynthetic algae. I just feel like no one's going to say that. 2.7 billion years ago, that means going to be algae. Yeah, it's 2 marks because 1 mark for photosynthesis and 1 mark for algae. So we're not going to mention trees because right now we haven't even got any plants. Right, so 2.7 billion years ago, that's when we've got algae doing photosynthesis. About 1 billion years later, so about 1.7 billion years ago, that's when we got plants, right? So there's literally 1 billion years of photosynthesis going on. You would not get a mark for photosynthetic life because your specification says algae, so that is what they want. Ah, the algorithm knows. Could you not talk about water vapor condensing? So water vapor condensing is not going to give me any information about why oxygen rose. Okay, describe and explain how the proportion of carbon dioxide changed in the Earth's atmosphere between 4.5 and 3 billion years ago. So there's a bit of a clue here. No, definitely no trees. No trees for a long time. Yes, this is combined. There's a bit of a clue here because we've already had something about photosynthesis. But actually, even if they hadn't included this, then we couldn't put photosynthesis in here because it says 4.5 to 3 billion years ago. So this is before those algae evolved. Okay, so you cannot talk about photosynthesis if we're talking about 3 billion years ago, because there was no photosynthesis 3 billion years ago. If you are just joining us and you want to know where the questions are, you can find them at this very fine address here that I'm about to make pink. Meow. All lowercase. So photosynthesis would be 1 mark. This is a 2-mark question. 1 mark for photosynthesis, 1 mark for algae, because you are supposed to know about algae. Okay. So between 4.5 and 3. So this is not at the start. We've got all those volcanoes. So our carbon dioxide is decreasing. And the reason for that is that it is dissolving in oceans. And then being locked up in carbonate rocks. Or you could say sedimentary rocks, or you could say carbonate sediments. The dinosaurs were 65 million years ago. Sophie, I'm loving the snail. So although I know this is partly my fault because I have a snail on my PowerPoint. It's not actually a snail, it's plankton. And they come a little bit later, okay? So up to 3 billion years ago, at that point, we're not talking about biological things, we're just talking about the chemistry of it dissolving in the oceans. And then a little bit later, we get our photosynthetic algae, and then eventually we get some plants, we get some animals, and we start getting all that stuff. Cool, right. Carbon dioxide is a greenhouse gas. Explain why greenhouse gases are important for life on Earth today. Oh, I just saw a really nice one and then other people answered and it went by. Yeah, so it's this idea that if we didn't have greenhouse gases at all, then it would be uninhabitable because it would be so cold. On YouTube, I'm not sure if it's Maria or Mariana, but mentioned that greenhouse gases trap infrared rays even better. So they maintain high enough temperatures for life. So basically, without greenhouse gases, it would be about -50, and we would all die. Okay, so 3.5 has got loads of different answers. In fact, it's got 6 different answers. Obviously, they've said 2 potential causes, so you are only going to write down 2, but we're going to write down all 6 because we're revising. No, I don't only do chemistry, I do biology and physics as well. You are already on YouTube, so you can click on my username and you will find resources for all of the sciences. I do have more chemistry than anything else because I teach mainly A-level chemistry, although I do teach biology as well. So yeah, I do have more chemistry stuff than anything else, but I do have all 3. Sorry for the TikTok peeps. It started making me fill in puzzle pieces and stuff. Oh no, how do I get you back on a nice angle? Oh, you were so nicely set up before. Help. Cool. Okay, so we've got 2 main greenhouse gases that we're interested in. First one is carbon dioxide. Saying it could keep Earth warm is probably enough if it's a foundation paper, probably not enough for higher tier. So, causes. We've got burning fossil fuels. We have got deforestation. Okay, we've got some people answering 3.6 at the same time as us doing 3.5. I am going to keep them very, very separate because, again, a really common mistake that we see is people answering a question about causes with effects or a question about effects with causes. So make sure you know which one we're talking about. So we've got burning fossil fuels, deforestation. Unfortunately, we blocked Yusuf, so he can't tell us what the third one is. This is chemistry paper 2. If you want to find the questions, you can find them at this link here. So causes is stuff that makes it happen. So like a cause of me being really fat would be me eating a lot of cake. An effect of me being really fat would be me not being able to fit indoors. Or a cause of me having lung cancer might be smoking a lot. Don't smoke, kids. It's bad for you. Also, I don't. And an effect of me having lung cancer might be me coughing a lot. Exactly. Peat bogs. Destroying peat bogs. Okay, someone in the chat is asking what deforestation means. So while I'm writing this, who would like to explain it to them? Exactly, cutting down the trees. And yeah, this is common content with biology. Could have come up in biology paper 2, but it is also chemistry unit 9. Right. Oh, I was going to ask you what other greenhouse gases there were, but I've realised I just wrote CH4, So a peat bog is basically, it's almost like a cross between a fossil fuel and compost. So it's where vegetable matter has decayed very, very slowly to produce kind of like compost, but that has a lot more carbon locked up in it than compost. And people dig it up to use it as fuel and also to put it as a fertilizer on their gardens, and it releases a lot of carbon. Right, so we've also got 3 potential causes of greenhouse gases, of greenhouse gases that are linked to methane. So we've got our cattle farming. Saw someone put that in the chat. Went by too fast though, so I didn't catch their username. So cars is not going to be this one. I think this is Scarlett giving me a very nice answer. Sorry, folks. It's really hard. If you've got a italicized username, it's really hard to read it on the background. Cattle farming, rice farming, and landfill. Good stuff. Right, and then effects. So this is then, yes, this is combined science. Things that could happen because of this, okay? I love the way how I specifically said at the start of the question, look, we only have to write down 2, but we're going to write down all 6 because we're revising together. And then people are still like, oh, you only meant to write down 2. Right, loving melting ice caps. For anyone who didn't say melting ice caps, we're going to really, really emphasize the fact that it's got to be ice caps. We are not getting any credit for ice. We are not getting any credit for icebergs. It's got to be ice caps. All right, sea levels rising. Flooding. Extreme weather events. So ice caps. If you imagine that the whole of the UK was covered in a massive sheet of ice, that would be a very small ice cap. So when you go to Antarctica, there are like millions of square kilometers with a layer of ice on them. That is an ice cap. So it is several thousand times bigger than an iceberg. And that's why melting is such a big issue. Okay, we've also got extinction of Arctic animals or polar animals. Polar is probably better. And destruction of polar habitats. So we want to be as specific as we can be here. We don't just want to say extinctions and habitat destruction. Yes, we could say droughts because droughts occur in different places. To the person who's asking about topic 7, we did quite a lot of topic 7 at the start of the evening. So I think we probably can't go around to it now. Right. Screenshot time for anyone who wants it. While I have a sip more Coke. Yeah, so to the people talking about tropical storms, that would be these extreme weather events. Okay, right. The next request that I had, yes, I was going to say it was the phytomining and the bioleaching, wasn't it? Okay, so Put those up there. Okay. Let's talk ores. So ores are rocks that contain metal compound for it to be financially worthwhile to extract it. Yes, aluminium oxide would be okay for zeolite. Okay, and then we've got high grade and low grade ores. So high grade ores contain a lot of that compound, and low grade ores contain less than 1%. And we are running out of high grade ores, right? These high grade ores, we don't have enough of them anymore. And so that's obviously really, really challenging. So we need to have some new ways of extracting metal from low grade ores. And this is where we get our bioleaching and our phytomining. So these are both biological processes. In other words, they both use living organisms. So bioleaching uses bacteria. So that's nice because we can remember B for bioleaching, B for bacteria. And phytomining, even though it sounds like it starts with a F, starts with a P. And phytomining uses plants, specifically hyperaccumulator plants. Okay, so bioleaching. So yeah, if it's a low-grade ore, it's still worthwhile, but it's more time-consuming. And you're not making as much money from it, and it's just, not ideal. Hannah, are you taking foundation tier? Because bioleaching and phytomining, they are in combined science, but only higher tier. So no, they're not triple, they are combined science. Okay. So when you have bioleaching, the bacteria are extracting metal from the ore. And it's especially useful where you've got something like a mining site where you've got tiny, tiny pieces of copper left in the soil. Moving it to the left is a little bit challenging because then it's like going underneath my tripod. Yeah, no, I can't make that work. Sorry. So the bacteria are not the leachate. The leachate is the liquid that the bacteria make. And that leachate then contains the metal. And so we then need to do either electrolysis or displacement to extract. Now, obviously, electrolysis and displacement in their sort of detail, those are paper one topics that we're not expecting to need to know a bit about. So reverse osmosis isn't about getting metal. Reverse osmosis is about getting pure water. Yeah, see, I mean, you could talk about the fact that they extract the metal by breaking the bonds in the compound. But very often bioleaching is just kind of a couple of marks and they don't want that much detail. Okay, so good things. Doesn't release any carbon dioxide. Bad things. Very, very slow. All right, phytomining. We're going to grow these plants on soil that contains the metal compounds. And the plants absorb them. Oh no, we've gone below 200 for the first time. Oh, this is awful. Guys, I think it might be time for another round of sharing, if that's okay with you. See if we can get a few other friends in the chat. Okay, so then those metal compounds are locked up in the plant. It doesn't have to be copper. It's very, very commonly copper because the price of copper is going up and up and we're running out of copper so rapidly. But your specification just says metal. Right, exactly. So we're going to burn the plants. So now the metal is in the ash. And so we dissolve that ash in sulfuric acid. And then again, we use electrolysis or we use displacement. So this is going to be a little bit faster, but it is going to release a lot of carbon dioxide. Which is, not great. Yes, so basically, these are going to get the metal out of the ground, but then they're still in something else. They're still not pure. I imagine that the phytomining would be more expensive because it's more energy intensive. Okay, options. We've got some questions about potable water. We've got a whole load of 6 markers about some of the practicals. Yeah, absolutely. It is carbon neutral, but it has still come up in the past about it being a disadvantage about it producing carbon dioxide. Oh, I reckon we're an even split of potable water and 6 markers. Tell you what, we'll do 1 potable water question and then we'll do some 6 markers. Right, which potable water question do we like best? That one's probably shorter. Okay, this question is about water. A student wanted to investigate the dissolved solids in 50 centimeters cubed of seawater. What apparatus should they use to measure 50 centimeters cubed of seawater? Measuring cylinder. No, I'm not going to do Edexcel because I don't teach Edexcel, so I don't know anything about Edexcel. I was just like, oh, I'll help my own year 11s revise. And then all these randoms turned up. Okay, so actually, if you did say a burette, it would be a perfectly valid answer because that would give you a really accurate volume. It would just be a little bit extra. Okay, describe a method to determine the mass of dissolved solids in a 50 centimeter cubed sample of seawater. Oh, hold on. Can you please go back at the end of the live so I can screenshot what I've missed? What I'll probably do, Hannah, is just take a load of photos and upload them as like a new thing because that's probably just easier for everybody involved. Okay, so I'm going to need to measure out my 50 centimeters cubed of water. And usually I would say using a measuring cylinder. This time I probably wouldn't bother because it's in the previous question, but and then if we're doing 50 centimeters cubed, we're probably going to have to do it in a beaker. Yeah, absolutely. I strongly encourage you to bullet point in your exams. It makes your marker's life so much easier. So yeah, if you've got an I in there, then it's the biology reagent that you use for testing for protein. If you've got no I and double T E, that's where we're thinking the measuring apparatus for chemistry. So this is not well, it's kind of a little bit in the required practical because one of the things is about how you can test for the purity of the water after you've purified it. And so testing for dissolved solids, that is one of the ways that you can look a little bit at purity. So I wouldn't call the call it the required practical, but it kind of is linked. To the people saying, isn't concentration paper 1, I've got news for you folks. Did you not know that moles can be examined in both papers? Check out 2024. So there is a section to your specification called fundamental topics, and they are topics that can be examined in either paper. And for chemistry, it's topic 1, topic 2, and topic 3. Cool, right, so we're going to measure out that. We're going to transfer to a beaker. Oh, wait, no, hold on. Before we transfer it to a beaker, we've got to measure the mass of the beaker. And what are we going to measure the mass of the beaker with? If anyone says scale, I'm going to fight them. Using a balance. Good. Well done. You have been well trained. So we're going to transfer our water to a beaker. We're going to heat until dry. We're going to measure the mass of the beaker and solids again. So if you were doing a very small volume, you would probably do it in a watch glass or in an evaporating basin. But because we've been asked to do 50 centimeters cubed, that is a huge volume. No evaporating basin is holding 50 centimeters cubed. So that's why I'm doing it in a beaker. Yeah, so I've said heat until dry. If you said until the mass is constant, that would be another way of expressing the same idea. No, it's not Edexcel, it's AQA. Right, a scientist collected 9.60 grams of sodium chloride from 250 centimeters cubed of seawater. Calculate concentration in grams per decimeter cubed. Now, we are smart humans, and we can say that per means the same thing as divide. So we're doing grams divided by decimeters cubed, but we don't have decimeters cubed, we have centimeters cubed. So 250 divided by 1,000 is 0.25 decimeters cubed. Then we're going to say concentration is mass over volume. So 9.60 divided by 0.25, which is a number. 9.6 divided by 0.25, 38.4. Oh no, what's going on? Other than the calculation. I'm really glad you corrected yourself even there, Ilse, because I was concerned for a second there. No, so this is GCSE. We wouldn't be having our grams per decimeter cubed if we were doing A-level. So there's no equation sheet for chemistry because there is no equation sheet for chemistry. So for physics, the sheet that you get always existed. It's just that since COVID, you get given it for the exam. But chemistry does not have an equation sheet. Yeah, so deci means a tenth. So 1 decimeter is a tenth of a meter. So that's about 1 decimeter. I have got some more on potable water, but people did ask me to do 6 markers. So we'll do some 6 markers, and maybe if we can... It does look like we're going a bit later than 9, doesn't it? Because people are doing well at inviting friends to the chat. No, so when the new GCSE started, Michael Gove was very much like everyone needs to remember everything. And so the equation sheet was taken away. And all the teachers said, this is really, really silly. This is not a good use of people's time in physics because it's just memorization rather than using things. And so So we didn't have it for the 2018, 2019 exam seasons, and then 2020, obviously there were no exams. And then part of the measure when we came back from COVID was, okay, we'll make life a little bit easier for people, we'll let them have the equation sheet. And then they've just kept it ever since. Okay, so describe how to carry out an investigation into the impact of changing hydrochloric acid concentration on the rate of reaction between hydrochloric acid and sodium thiosulfate. So if they're going to ask you about this sort of thing, they do have to give you an equation for it, right? So even though this disappearing cross experiment is one of our required practicals, everybody knows it, everybody's done it, and every school does this equation, this particular chemical reaction. The chemical reaction itself is not in the specification. So they cannot expect you to remember this. You are not expected to know what sodium thiosulfate is, even though we all have it. So, cool. We need to make sure before we start answering this that we've identified what it is we're changing and what it is we're measuring. So we're changing hydrochloric acid concentration, right? That's my independent variable. And then my dependent variable, the thing that I am measuring, is the rate of reaction. I wouldn't recommend bringing this one into the exam hall because it makes sulfur dioxide, which, as we were talking about earlier, is not nice stuff. It makes some acid rain, it causes respiratory distress, not good times. So that's my dependent variable. And then my controls, we're going to have things like the total volume. We're changing the acid concentration, so we're going to keep the concentration of the sodium thiosulfate the same. Okay, so I'm just going to do myself a little reminder of these things before I get started. Okay, now, like we keep saying, really strongly recommend that for methods and things you do bullet points, you do numbered lists, because it makes it much easier for your marker to follow what's going on. And when you, especially something like this where you're going to be like, oh, repeat everything and change this one thing, it means you can say repeat steps 1 to 8. So we need to change the acid concentration. So what I'm going to talk about is I'm going to say measure 2, 4, 6, 8 and 10 centimeters cubed of hydrochloric acid in a measuring cylinder. So I'm doing that because I'm going to dilute these down. So I'm then going to top up each cylinder with water to make 5 different samples of 10 centimeters cubed hydrochloric acid with different concentrations. So people who are saying, do I need to say pure water, distilled water? Yes, you should use distilled water, but in the context of a grade 4 question, we're going to assume that if you say water, you mean pure water. Folks in the chat, I'm going to need you to take over again. Okay, so I've got my different concentrations. The actual volume I've gone for is not important. If you said 20, that would be totally reasonable. If you said 50, I'd laugh at you a bit, but that would still get you marks. You're not sort of expected to know what a reasonable volume is. Yeah, if you just said about doing 10 and then at the end you were like, oh, repeat it with concentrations of hydrochloric acid that you diluted, that would be okay. So I'm then going to measure 10 centimeters cubed of sodium thiosulfate. Watch out for the fact that if you have got a chemical that you're not super familiar with, double check that you are writing the name of that chemical right. Like, I'm not saying you're not going to lose any marks for spelling, right? As long as it's phonetic and we know what you mean, that's okay. But what we very often see with this practical in particular is that people start saying measure measure 10 centimeters cubed of sodium. 10 centimeters cubed of sodium would be a blooming big mass of a solid metal that would just make everything explode. So this bit here, the people who are asking in the chat, is because I need to change the hydrochloric acid concentration. And the way I'm doing that is I'm having, if you imagine like a bunch of glasses and you were making squash, you put a little bit of squash in the first one with lots of water, and a bit more squash in the second one with a bit less water, and a bit more squash in the third one. Yeah. So what I'm doing is I'm explaining how I'm going to change the concentration. And very often I wouldn't need to do that, but we have had a question, I think 2 years ago, where in order to get full marks, you did not need to talk about how you were going to change the concentration. So now I always encourage people to do that. So this is where we're going to get our cross. I'm just going to say a pencil cross. Now, you might want, if you're being really, really detailed about this, you might also want to talk about heating this in a water bath to make sure everything's the same temperature. Right, people who are getting confused, I've got some space in the back of this. Right. In this experiment, I've been asked about changing concentrations, right? So that means that in order for me to see how concentration affects it, I'm going to need a bunch of different concentrations. And let's say that I don't have a technician who is just going to make me up a bunch of different concentrations. So what I'm going to do, this is my acid, okay? So I've got 5 different measuring cylinders with different volumes of acid in. And then I'm going to fill them all up with water, right? And obviously mix them, right? I'm not just going to leave the water sat on top. So if this one had a concentration of 1, then this one that was 4/5 acid and 1/5 water would be 0.8. Yes, I will put the question back in a second, but I can't explain this without drawing it, so you're just going to have to bear with me. And this one would have a slightly lower concentration, and this one would have a slightly lower concentration, and this one would have a slightly lower concentration. Yeah? So what we're doing is we're diluting our acid down. Bond calculations for AQA were paper 1. So no, we're not going to revise that tonight, because if you're doing GCSE like the rest of us are tomorrow, that's not something that you need to revise. Okay, so we're going to put it over our pencil cross, and then we're going to add 1 centimeter cubed of acid to the sodium thiosulfate. Obviously, you are fine to write the word sodium thiosulfate. Yeah, so in this question, we're changing the acid concentration, so therefore we've got to keep the sodium thiosulfate. Yep, so I did mention before we flipped over the page that that you could talk about using a water bath. To the person in the chat saying that bond energy calculations are paper 2 for triple, I'm guessing that means that you're not taking AQA, because for AQA, they are 100% unit 5 energy changes, which was paper 1 for us. Okay, so next up, we're going to time how long it takes for the cross to disappear. A pencil cross is a cross that you drew with a pencil. So a McCartney bottle is just something you would use. If you're doing this on a small scale, which is what I'm describing here, then a conical flask is too big. Nope. So I did say when we started going through this question that you are not supposed to know this experiment, even though I guarantee you've done it. It's not listed in your specification. That's why they have to give you the symbol equation. Yeah, so absolutely. They can ask you, with the rates topic, they can ask you to look at, they can ask you to look at pressure, not for this reaction, but for other reactions. If it's for it to count as the required practical, it has to be concentration. So you know how 15% of all the marks have to be for required practicals. It only counts as the required practical if we have concentration. But temperature is also in the specification, so they could ask you this same question but changing temperature, and that would be an entirely valid thing for them to do. It just wouldn't count towards that required practical quota. If they asked how we could improve the accuracy, okay, this says 1 to 7. Sorry, I'll do a 7 like that to make it clearer. So when we say top up each cylinder with water, that means the water is going there, and the act of pouring in that water and then pouring the whole thing out again is going to mix it. So for this particular experiment, you can see that you've got a solid in there, and therefore it's going to be our turbidity one. So the reason I've got somebody on YouTube asking about heating with a Bunsen burner, the reason we wouldn't heat this one with a Bunsen burner is that this reaction produces sulfur dioxide, and sulfur dioxide is quite dangerous. Sorry, people are pointing out that I should have actually said repeat steps 3 to 7. I apologise. I'll be better in future. This reaction gets dangerous if you do it above 55 degrees C. If I was heating it with a Bunsen burner, firstly, it would go above 55 degrees C. And so that would be dangerous. But also, the point of doing it with a water bath is I'm not trying to make it hot. I'm trying to make it the same temperature. So that would be if I was using temperature as a control. So I would have a water bath at something like 30 degrees. Whereas with a Bunsen burner, I'm going to end up with a much less controllable temperature. So Chloe, what I was saying a little bit earlier was that in the past, it's generally been okay to just say, repeat it with different concentrations. But there has recently been a question, I think it was actually on the triple paper, and I think it was talking about chemical cells, and it was maybe 2 years ago. And they specifically wouldn't give you the marks unless you talked about how you change the concentration. So that's why I've gone through how to change the concentration, because as you can see, a lot of people very confused about it. So if I was going to change the so Eman, if you're not given any further guidance and it's just one that produces a gas, then you could collect the gas or you could use a balance. Either one of those would work. And if the temperature was changing, I would still stick with a water bath, because you want control over that temperature. You want to be able to specifically say, this is 30 degrees. No idea, never taught WJEC, no idea what's in it. Okay, we did some fractional distillation already, so I'm not doing that one. We haven't done chromatography yet, so let's do some chromatography, because it's another required practical and people wanted to do required practicals. So we're describing how to carry out a chromatography experiment to investigate the colours in an ink. It used thiosulfate because that's what the question said. Right, okay. So first up, we are going to draw a start line, a pencil start line, at the bottom of the chromatography paper. Why am I drawing it in pencil? Oh no, we've dipped below 200 viewers again. Good. So pencil is insoluble. It won't run. So it's not going to interfere with any of my results. Okay. So then usually we're going to have something, we're going to have like a mystery one that we don't know about. And then some things we're going to compare it to. Guys, it's literally called the 6-mark challenge. Yes, it's a 6-marker. So we're going to have some things that we already know about on our start line. And then we're also going to put a dot of our unknown ink. Okay, so we're then going to place the bottom of the paper in the solvent. And what do I need to be really, really super careful of when I'm doing that? When I'm thinking about how I'm positioning it. So the start line is not the same thing as the solvent front. The solvent front is where the top of the wetness is on the paper. Absolutely. So we want to ensure that that solvent doesn't touch the start line. Or you could just say something like ensuring that the pencil line isn't under the solvent. Now, if they haven't specified, you probably can just say water rather than solvent. Okay, then we need to wait for a little bit. We're going to leave it while the solvent is rising. And basically, the longer we can leave it for, as long as our piece of paper is long enough, the better it's going to be, because the more that the inks are going to spread out. Then once the solvent is near the top, remove and dry. So mentioning using a lid is one of those sort of added extras that could get us our 6th mark. But you only actually need a lid if you've got a volatile solvent. So if I was going to do this practical with ethanol, I would definitely want a lid on it. If I was going to do it with water, water's not going to evaporate unless it's a very hot day, so I wouldn't bother. What do you mean about solvent near top? Does the water travel up or the ink? So the water travels up, and as it travels, it pulls the ink with it. So if you, I mean, you could go get a bit of paper and do this in the kitchen right now. But basically, if the water starts down here, it will rise up, rise up, rise up. And as it does so, it pulls the ink. And the more soluble the ink is, the further it gets pulled. Yeah, you could say the solvent front was near the top, because if the solvent is near the top, the solvent front will be near the top. Okay, so then we are going to compare the position of the colours from our sample to the known inks. And we're probably also going to calculate RF values for each colour. And ideally, we also want to repeat using a different solvent, because different colours have different solubility in different solvents. So you might have 2 inks that have the same solubility in water. And so in water, you can't tell that they're different to each other. But in ethanol, they have different solubilities. So stationer sells stationery. So that's like W.H. Smith. And stationary means not moving. Oh yeah, that should say bottom. Sorry, I got distracted. Yeah, I know it's not W.H. Smith, but I can't remember what it is called now. Right, people asking about the RF value. RF value is going to be distance travelled by the sample divided by the distance travelled by the solvent. You're really keen on the polymers. Did you watch the video I did earlier on polymers? I put a video up at about, I want to say 6:30 on polymers. All the people who were like, wait, polymers was paper 1. If you're doing combined science, polymers is paper 1. If you're doing triple science, then both. So the reason for repeating with different solvents is because dyes and things have different solubility in different solvents. So say you could have 2 inks that have the same solubility in water, and so they both go up at the same speed and they stay stuck together and you can't tell the difference between them. But if you put them in a different solvent, they have different solubility, and so you can see those different spots, and so you know that they are not they're not the same as each other. Right, cracking. What can we say about cracking? Let's have since either there's lots of people asking about cracking or the same person who's been asking about cracking is asking a lot, I'm going to concede because we haven't talked about cracking a huge amount. So, cracking is the thermal decomposition. So thermal means using heat, and decomposition means breaking down. Oh, TikTok's getting angry at me because there aren't enough people watching. Shush, TikTok. Like, encourage your followers to send you more gifts. I don't even know what a gift is. So, Bobby, it's not a word that you're going to be expected to define, but if it's, I'm trying to think of what they could ask you. Something like, explain why a Bunsen burner is necessary for thermal decomposition. Oh, because it needs heat. Okay, so we're going to use cracking to break down large alkanes to make smaller, more useful ones. And one other type of molecule. So what other type of molecule are we going to make as well as alkanes? I like people saying alans. Yes, alkenes. So there are very, very few words in GCSE science that we need to spell correctly, but alkanes and alkenes are them. Now, we said that these smaller alkanes are more useful. Why are they more useful? What property do those smaller alkanes have that makes them more useful? Might help if we think about what they are used for. They've got shorter chain lengths. Yes, absolutely, Dylan. They are more flammable. So we know that lots of alkanes are used as fuels, and the smaller ones are more flammable. They make better fuels. This 100% is a QA spec. Okay, and then the alkenes, what do we tend to use them for? Right, so we use alkenes to make polymers. And a bunch of other molecules that you only need to know about if you're doing triple. Yes, they are unsaturated. Okay, so we've got 2 types of cracking. What are my 2 types of cracking? Catalytic and steam. Now, I really wish they wouldn't call them catalytic and steam because it makes it sound like there's no catalyst in steam. But steam cracking does have a catalyst. The catalyst is steam. So, catalytic, we're going to have, we want a zeolite catalyst and high temperature. Steam cracking, we're going to have steam and a high temperature. Okay, no mention of pressure. Yes, we can say aluminium oxide instead. Sorry, I've been revising with year 12 too much. Okay, so we also need to be able to finish off some equations. So we've got a couple of different types we could have. We've got ones like this, where they say, what's the second product? I mean, right now, this isn't really an anything marker. This is just me teaching cracking. So CnH2n plus 2 would be the general formula for an alkane. Oh, Sophie, I love that. May I steal that? Because that is such a common thing that people don't remember. Okay, so we're going to have C20H40. And I can tell that because the 10 and the 20 together add up to make 30. And the 22 and the 40 add up to make 62. Thank you so much, Sophie. I really appreciate that. Oh, I should say it out loud for the people on TikTok who see you. So Sophie on YouTube said, guys, don't mention pressure in cracking because don't crack under the pressure, which I love. Okay. So that's one type of cracking equation. The other one we could get, let's not make this not too hard. Give me a second to think. So we're going to have is one like that, where they tell you both of the products, but they want you to balance it instead. So it's still going to be true that everything on the right has to add up to be everything on the left, but now we need to be a little more thinky about it. Oh yeah, everyone's just going straight for 10. I made it too easy for you. Okay, so for people who are going, oh God, I don't understand what's going on, 40 is 20 plus something. So obviously that's going to be another 20. And then each one of these has got 2 carbons in. So I'm doing 20 divided by 2 gives me 10. And I could do the hydrogen as well, and I would get the same thing. Okay, I think that's kind of everything that we need for cracking. I suppose what we should have is how could I prove, say if I captured this ethene here, how could I prove that it was an alkene? What test would I do? What am I doing? I'm going over cracking. Right, absolutely bromine water. Got to be bromine water, not just bromine. And it turns colourless. What colour is it to start with? Orange to colourless, even better. Cool, cool. Right, that was cracking. Anyone want screenshots? Last opportunity. Yep, that's all combined. Nothing on there for triple. I've been very mean to the poor triples. I've kept saying that I'm only doing combined stuff. Absolutely ills. Since always has there been quantitative on paper 2. So the new specification, we started teaching, first examinations were 2018, so we started teaching in 2016. So since then, the fundamental topics which can come up on either paper are atomic structure, bonding, and quantitative chemistry. Yeah, absolutely still beneficial for triple because everything that you need to know for combined is in triple. So this is all stuff that you need to revise. If you are doing triple, then yes, you do need to know about addition polymerization. Oh, okay, look, can you please tell me the required practicals combined higher on chemistry paper 2? Go on quickly before we do another question. Our required practicals are going to be, we've got 2 rates ones. So we've got collecting gas and turbidity, aka the disappearing cross. Turbidity is what the exam board call it. Disappearing cross is what everyone else calls it. We've got chromatography and we have got water purification. And since you mentioned it, give me just a second. Let's find Dr. De Bruin required practicals chemistry paper 2. All right, I'm going to rotate these one after the other. Sugar. I'm going to throw my phone on the floor instead. Ah. Right. Sorry, I can't do both phones at the same time. So, if you are looking for more required practical shenanigans, sorry, TikTok people, you'll get your turn in a second. There is this very nice video on YouTube called Every Required Practical in AQA GCSE Chemistry Paper 2. It is 22 minutes long, and I go through all of the required practice there. Oh no. Oh, that phone's going to fall out now. TikTok people are like, what's going on? So that is the one. So to the people who are saying anion and cation tests, halide tests, that is all in that video as well. Yeah, cations is, it's partly your flame tests, and then it's also your hydroxide ion testing. So, what am I even doing here? So adding sodium hydroxide, and if it's calcium or magnesium or aluminium ions, you get a white precipitate, and if it's copper, you get a blue precipitate, and if it's iron 2+, you get a green precipitate, and if it's iron 3+, you get a brown precipitate. Oh, that was a lot. Okay, right, back to the 6 markers. Oh, where have I put them all? Okay, we did. So to get those precipitates, you add sodium hydroxide. We did do quite a bit on atmosphere already. That's an evaluation one. That's the other required practical. Oh, I'm bored of all of these. Let's do an equilibrium one. So this is the context of the Haber process. If you, I've already done so much potable water, guys. So much. Naya, if you're doing triple, then yes. If you're doing combined science, you are not supposed to know that this is the Haber process, but you are supposed to be able to answer questions about equilibrium. So you can absolutely be given, if you're doing combined, you can be given the equation and told that it's exothermic and then expected to be able to write about it. If you're doing triple, you are supposed to know that the forward reaction is exothermic and you are supposed to know the formula for it. But yeah, like we say, if you're doing combined, you could absolutely still get this question. Okay. So things that we know. Forward reaction is exothermic. It's a reversible reaction. It has to be, because otherwise it wouldn't be an equilibrium question. And we can also look at the numbers of moles of gases on either side of the equation. So if we look here, we've got 4 moles. And if we look here, we've only got 2 moles. So things that we're going to think about. We're going to think about how much the yield is going to be and also what the rate of reaction is going to be. So if we increase the temperature, that will shift equilibrium to the left. And I know that because they told me that the forward reaction was exothermic. So that would reduce the yield. Or in other words, we would make less ammonia. However, if we reduce the temperature, what's going to happen to the rate? Yeah, it's because I said I would only go until 9, and so everyone is watching Love Island instead. Right, exactly. It's going to slow down. So for the sake of yield, I want it cold. For the sake of rate, I want it hot. Yeah, temperature is different from pressure. We're going to get to pressure. We are going to talk about pressure, but firstly, I'm talking about the temperature. So we're going to pick a compromise temperature. We're going to pick a temperature that is somewhere in the middle. Something like 450 degrees C, say. Okay, so then we talked earlier about pressure. We can see that we've got more moles on the left-hand side here. So that means that if we increase the pressure, we're going to push to the right. So what I was saying, Dylan, is that this question definitely could come up as a combined science question. If you're doing triple, you're expected to know some of the information you've been told. So you're expected to know this equation and you're expected to know the forward reaction is exothermic. But if you're doing combined, because they've given you the equation and because they've told you it's exothermic, you can still answer this. So you've got more moles of gas on the left hand side. So increasing pressure shifts equilibrium. Oh, one of my kids is in the chat, but they have a hidden username, so I don't know who they are, although I have a suspicion. I believe that is one of my year 7s. Okay, so that's also going to increase the rate. Oh, bother. Sorry. But we're not going to have the world's highest pressure because high pressure is expensive. Because we need sort of specialist equipment. Oh, sorry, crampy hand. Oh, Esther Legend is getting ahead of us. High pressure is expensive to produce and dangerous. So again, we pick a compromise. And then the one piece of information that you would only know if you're triple, like this could be a 6-mark combined, but if you're doing triple, you should also know that we use iron as a catalyst. Because it allows you to use a lower temperature. But that is just for the triples. So let's put that in a different color. Okay, so I'm getting a question on YouTube about composites and matrix and binder. So matrix and binder mean the same thing as each other. And then the reinforcement is the bit that goes in the middle. So if you've got, you'll have something like this. This is your reinforcement. And then this is your matrix. Yep, I will go back. Triple is a lot less extensive than it used to be. Like, you guys don't know you're born. The old spec that we taught up until 2017, rather than just having half an hour longer, the triples had a completely separate paper. So they would have, rather than having like little bits of extra information in all the topics, they just had, like how for physics, you have space is just for triple. It was like that. So no, for triple, you're not supposed to know whether it's exothermic or endothermic. It's just that this particular reaction that I've picked as the context for this question, that is a reaction that the triple scientists study in the using resources topic. So they are supposed to know that this particular reaction is exothermic in the forward. Cool. Right. I said I would go until 9, and it is now 9:30. Thank you very much, folks. You have been fab. If you do want to go over any of the other questions that we didn't get to or any of that kind of stuff, the original ones that we were going through at the start and all of these 6 at bit.ly/aqchem2. That is all lowercase. Yeah, as soon as I've hung up the phone on all of you guys, I will take a shed load of photos and just post like a little series of photos. And that way, if you want to go back and screenshot anything that you missed, you can do. Omar, big with the sarcasm. Right, thanks, folks. You've been a joy. Thank you for participating so well. I hope the rest of your revision well. Yeah, I thought it might be Luciana. And make sure you get some proper sleep, okay? Right. Because I promise you, you will do better on a good night's sleep than you will on cramming all night. Yeah? Oh, dear. Right. Have a wonderful evening, everybody.